This is a continuation lecture of the top environmental problems that we face on the Earth. Yesterday we talked about habitat destruction, which is the first of the H's. Well, the first H in HIPPO, our acronym for all the top environmental problems. The second one is invasive species. And invasive species are basically species that are non-native. That means they are not from the area. They come from another country, and these species are accidentally or purposefully introduced to an area. So it's accidental or it's purposeful. A lot of species that we have that are non-native are actually ornamental. So if you go into a place like Petiti Garden Center or whatever, a lot of the species there for landscape are non-native, and they then are purposefully planted. Now, in order for non-native to become a problem, because not all non-natives spread very fast, but some do. But if they do spread really fast, then they become invasive. And we've really had a really big problem with invasive species, especially in Ohio, and it's mainly because of a route system that we have for shipping. That's the Erie Canal, and the canal that the St. Lawrence Seaway is what they call it, that connects the Atlantic Ocean to the Great Lakes, which brings in lots of ships. So the way they get here that way is definitely accidental. And what happens is, here's a big ship, and in order for ships to travel from ocean water into salt water, and ocean water into fresh water, and then fresh water into salt water, they have to maintain buoyancy in the boat. So as a result, they put stuff into the boat called ballast water, which is basically water from wherever they're docked. And this ballast water actually contains organisms. And so these organisms are all in here, and the ship makes its transatlantic journey to the U.S. And then in order for the ship to maintain proper buoyancy, they have to dump that water out, and they dump it into the nearest waterway that it's in. And then all of those organisms, if they have a wide ROT, and if you remember from yesterday, ROT is range of tolerance. So if they have a wide range of tolerance with regards to dissolved oxygen levels in water, pH in water, salinity in water, any of those abiotic factors, then they will survive. And then if they survive, then the chances are that they will successfully reproduce and really take over an ecosystem. And so that causes a problem, because if they start to increase in numbers, a lot of times non-natives or invasive species do not have any predators. They don't have any predators because they didn't evolve here. So as a result, they have free reign. They can exploit resources at a faster rate than natives, and so it causes some serious problems. And we'll get into the specifics later on in the year. Some examples of non-native species that we have here in Ohio, specifically Lake Erie, is the zebra mussel, and we have some specimen to pass around for you to see. Zebra mussels are a type of bivalve. They came from the Caspian Sea, and they got here through the ballast water of ships, and they got into the lake, and they are a benthic organism. So that means that they live on the bottom. They live on a surface, really. They will grow anywhere, and they colonize the surface, and they filter water. Before they came here, we had freshwater clams in Lake Erie. Since zebra mussels have been introduced into Lake Erie, the freshwater clam populations have gone down, and zebra mussel populations have gone up. And so there's definitely some competition here, but the freshwater mussel, or freshwater clam, is actually losing. So they occupy the same type of habitat. And so when you have two different species that occupy the same habitat, it is called a type of competition. It's called interspecific competition. And this is competition between two different species. Okay? So one species is competing with another to occupy the same niche or habitat. We also have another type of competition called intra-specific competition. Intraspecific is the type where you have competition between members of the same species. And with the zebra mussel, they are notorious for this. They fight with each other for habitat and so on. And I don't mean fighting like they get up and walk around and fight, but they definitely are competing with each other at a high level for habitat and food. The picture here that you see is actually a type of vine called the kudzu vine. It's Kudzu. And the kudzu vine was purposefully introduced in the southeastern United States to control beach erosion. The kudzu vine grows up to 1 foot a day under ideal conditions. So that's pretty much, the length of a ruler. That's how much it'll grow in length every single day if it has all of what it needs in ideal conditions. As a result, this vine has taken over and it's created statues of kudzu vines. So these are kudzu vines that are growing on other trees and on limbs of trees that kind of create these statuesque type of vegetative statues, if you will, which actually are pretty neat to look at and see. If you've ever been down south and you've driven along I-95, which is the main interstate going down to Florida, you'll see kudzu vine in North Carolina, South Carolina, Georgia, and Florida. We're starting to see it spread up into Virginia, West Virginia, and Maryland, and eventually Kentucky and Ohio. So it'll definitely spread through there. Okay, so they displace natives. There's no predators, so it's very hard to control populations for many invasive or non-native species. And as a result, it changes the ecosystem that has evolved over millions of years. Okay. Next slide is pollution. We talked about all different kinds of pollution earlier last week. We talked about water pollution and air pollution. Here you can see air pollution. Pollution is basically a substance that's in excess. Unfortunately, a lot of these excess substances are man-made or byproducts of combusting fossil fuels. One of the main pollutants in air is carbon dioxide, along with sulfur oxides, which we designate as SOx, and nitrous oxides, which we designate as NOx. All three of these are the byproducts of combusting fossil fuels. So we burn fossil fuels to convert that energy into mechanical energy, which then becomes electrical energy, and that's what we use to power things. The problem is that there's byproducts of burning fossil fuels like these three here, and all three of these hold heat. Okay, so as a result, yes, we have pollution, but there's so much more that happens as a result of producing that pollution. And we call that change. This is a change in one direction that leads to further change in the same direction, kind of like a snowball effect. So you start out with this. You start out with burning fossil fuels. Burning fossil fuels leads to a problem where we have lots of pollutants in the atmosphere. Those pollutants then cause even more problems with holding heat. Holding heat in the earth creates even more problems because most of the earth is made of water, and as a result of water and heat, you bring that together, then the water gets warm, you have an increase in evaporation of water, okay? So then you get an increase in water vapor. That's G for gas in the atmosphere. And when you have more matter in the atmosphere, it creates severe storms, huge storms like Hurricane Katrina that was 10 years ago. Um, that hurricane grew in size massively in a very short period of time, and it was simply because it had enough time to hover over the Gulf of Mexico, creating even just a huge storm compared to what it was just 24 hours prior to it hitting land. So when you have more matter, in the atmosphere, you're going to have more storms, and you're going to have severe storms and changes in storms where you'll get drought where it used to be the rainy season, or you'll get the rainy season where it should be a drought time of year. So this climate change, it used to be called global warming, and scientists have kind of renamed it to climate change because it's not just that the earth is getting warm, but the climate is changing, and it's changing at a rate that's way faster than historical time, like over time. Climate science, over time, it takes thousands and thousands of years for the Earth's temperature to change and this and that. We are changing the Earth's temperature in a matter of 150 years. So 150 years compared to thousands, tens of thousands of years of change is drastic. And so that's where that comes. We'll get into greater detail with pollution later on in spring, actually. So here's some examples of climate change. You may have heard of like the polar ice caps melting because the Earth's warmer, da-di-da-di-da. So as a result, then this is a domino effect too, where a change creates a bigger change, which creates a bigger change. So let's go back to the root of this ice melting, which is fossil fuel combustion. And when that happens, then the ice melts. And then when the ice melts, you have more liquid water, right? When you have liquid water, then you have more water that's available to become gas. Okay, so then the rate of evaporation increases even more because there's liquid water. We call this melting of the ice caps, going from ice to water. We call this thermal expansion of the oceans, meaning that these ice caps at either pole are becoming thin because they're melting away. They're becoming broken apart, and as a result of them breaking apart, that increases the surface area for it to melt even faster. And then what happens is you get more water vapor going into the atmosphere, which causes storms like you see here. This is actually a picture of Hurricane Katrina. Okay, so more matter in the atmosphere, that is a result of, if you trace this all back, the combustion of fossil fuels. Okay, when we have a change in one direction that leads to further change in the same direction, it's called a positive feedback loop. And the positive isn't it doesn't mean it's good. What it means is that it's growing. Okay, so it's called a positive feedback loop. Okay. Okay, so make sure you write that down, and I want you to know too that the stuff that I say and I don't write down, you should still try to get that written. What's nice about these lectures is you can replay it back and listen again in case you missed it. So make sure you write down stuff I don't technically write down all the time. And then we talked about population already with humans. We're just over 7 billion, and I think like 7 billion, like 300 million. And this is, I thought, a pretty neat illustration of populations and where they're located. And the higher the bar here, the greater the number of humans. But we also need to consider not only numbers, but like I said before last week, resource consumption per human. And we are going to be doing that ecological footprint later this week or early next week, where we will investigate, the resource consumption for you as an individual. And then the Earth at night. I thought this was a great illustration to show you where humans reside. So if you look at the Earth, you'll see that we pretty much are like 40 to 50 degrees north and south of the equator predominantly. So that means untouched territory is like near the poles, and there's obvious reasons for that. But just to give you an idea of where many humans are, and then even within the country where lots of humans reside. So if you look at the United States, what do you notice about the United States regarding human colonization? Take a minute to look at that. Now what I would like you to write in your composition book is why. Why, if you look at this, the eastern seaboard, or the eastern part of the U.S. is very well lit. That means there's lots of development there. The western part isn't as developed. So I would like you to answer in your composition book right now why that is so. Okay? I'll give you a minute or two to do that. I'm going to move on and finish up this lecture because I want to get it done within a few minutes here. So you can return to that question if you didn't have enough time. The O in hippo is overexploitation. And overexploitation is when we harvest or like kill and eat or kill and trade species from the wild, and we do it at rates that are faster than they can recover. So we overexploit them. Some examples are overfishing, overhunting. Those are two different types of overexploitation. And currently, about a third of the world's endangered vertebrates are threatened by overexploitation. So an example of an endangered vertebrate, and there's many different species of them, but sharks worldwide are declining because we're overexploiting them. Tuna is another example of a marine fish that we're overexploiting. There's been a huge exponential growth in sushi in countries that can afford it, and so as a result there's a greater demand for tuna and sushi grade tuna. As a result, there's more harvesting of it. But the problem is that our oceans are international. So one country's policies only are effective in their waters, but once you get beyond that, in the open ocean where it's international waters, it's kind of like a free-for-all. For the United States, we own 200 miles out, so from the coast to 200 miles, that is where we fish and harvest, and we have fisheries scientists that can help give us an idea of how much we should harvest per year and so on. So it kind of manages our fisheries a little bit better when we have that information. But when you get into international waters, it's a whole different story. And then you also have countries that maybe don't have fisheries scientists, or they don't value um, keeping track of populations. They just want to harvest, 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 which is overexploit, 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 because there's money, money, money. So, there's different policies, okay? And so with environmental science, it attempts to kind of explore those differences in policies and to come up with an international treaty or agreement so that countries are not overexploiting the resources that we have for future generations. I mentioned before sharks. So sharks, unfortunately get a bad rap. And as a result, internationally, sharks get killed for no reason. In some countries, they actually will take sharks out of the water, they'll cut their fins off and throw them back in the water, and then they dry the fins on the rooftops of buildings, and then they make a delicacy soup. It's called shark fin soup, which is really expensive, and so it's like in really nice restaurants in many Asian countries. And so the way that they harvest is obviously, well, you can think of it however you want to think of it, but it's just unsustainable. And so as a result, we've seen a decline in sharks globally, because not only because of that, but also because of just, you know, the prize of the hunt kind of thing. So like when I was in the Outer Banks this summer, my daughter and I went out on a pier and people were fishing on the pier, and there were actually shark fins nailed to the side of the pier for people to like touch and look at. And I was just so overcome with anxiety over it that I had to leave. So it's like, you know, people catch a shark and then they just want to kill it, and there's really no purpose. It's just the prize of the game, the fight. So, you know, there's a different way of doing things, and that's definitely not one of them. Okay, so this marks the end of the lecture. Make sure all of this information is on the right side of your composition book, and then for the rest of class, I would like you to output that information. So fill out the left side of your composition book. Okay, that's it.